In this video, we are going to talk about the gluconeogenesis from the other substrate, non-carbohydrate substrate. So we are going to talk about the gluconeogenesis from the oats and fatty acid, amino acid, methionine, isoleucine, and glycerol. First of all, let us talk about oats and fatty acid. The oats and fatty acid is converted to propionyl coenzyme A. So, as I have already told you in the previous lecture of the gluconeogenesis, from the oats and fatty acid, the one molecule of propionyl coenzyme A is obtained, and that propionyl coenzyme A is participated in the citric acid cycle, and gluconeogenesis can be commenced. Whereas the even chain fatty acid, it cannot be obtained. So, from the oats and fatty acid, propionyl coenzyme A is obtained, and with the help of ATP and biotin and with the action of the enzyme propionyl coenzyme A carboxylase methylmalonyl coenzyme A is obtained. And in the methylmalonyl coenzyme A, with the help of vitamin B12, the succinyl coenzyme A is obtained, and the succinyl coenzyme A participate in the citric acid cycle, and from that citric acid cycle the oxaloacetate is converted to malate, and from the malate malate gluconeogenesis commenced. The malate is permeable to mitochondrial membrane, whereas oxaloacetate is not permeable to mitochondrial membrane, as I have already told you in the gluconeogenesis. And after the malate comes out of the mitochondria through the mitochondrial membrane, it is again converted into oxaloacetate, and gluconeogenesis is commenced like that, as I have already told you in the previous video. And the amino acid except leucine and lysine, all other amino acid except leucine and lysine are converted to um, are participated in gluconeogenesis process, and methionine and isoleucine also converted to gluconeogenesis process, which can be converted to glucose. And through their amino acid except leucine and lysine, methionine and isoleucine, with their breakdown, methylmalonyl coenzyme A is produced, and succinyl coenzyme A is obtained, and from the succinyl coenzyme A, it participates in the citric acid cycle, is like that in the previous video I have already told you. It participate in the gluconeogenesis, so it served as the template for the gluconeogenesis. Yeah. So all the origin fatty acid, amino acid, methionine, and isoleucine are eventually converted to succinyl coenzyme A that participate in the citric acid cycle, and ultimately goes in the gluconeogenesis metabolism. Now let us talk about the formation of the glucose from the glycerol. Glycerol, with the help of glucokinase enzyme, is converted into the glycerol 3-phosphate. It mainly occurs in the kidney. So the glycerol 3-phosphate is converted to dihydroxyacetone phosphate with the help of enzyme glycerol 3-phosphate dehydrogenase with the conversion of the ATP to ADP. And dihydroxyacetone phosphate is converted to fructose 1,6 bisphosphatase, and fructose 1,6 bisphosphatase is converted to fructose 6-phosphate with the help of enzyme fructose 1,6 bisphosphatase, and fructose 6-phosphate is converted to glucose 6-phosphate, and glucose 6-phosphate eventually converted to glucose with the help of enzyme glucose 6-phosphatase. So the regulation of the gluconeogenesis I have already discussed in the previous video of gluconeogenesis, conversion of the glucose from the pyruvate. I request you to read that topic and see that video. So in today's video we have talked about the gluconeogenesis from the various substrates like oats and fatty acid, amino acid, methionine, isoleucine, and glycerol. I hope you understood this lecture. Thank you.